Hello everyone, my name is Golnaz, and in this video tutorial I'm going to teach you how to use the Python package MLNA, which stands for Multilingual Network Analysis. So what are the use cases of MLNA? Imagine you are doing research on the development of telegraph around the world. To do this research, you have a bulk of digitized texts at your disposal. These could be historical texts, letters, documents, and maybe there are documents among these texts, the language of which you do not understand, but nevertheless, you would like to integrate them in your research, depending on if the content is relevant to you. One solution would be to have all of the texts, the language of which you do not understand, translated for you. But what if in the end, after you perform a close reading of all of these translated texts, you figure out that their content was actually irrelevant to your topic of research? MLNA can help you get an overview of the content of these texts, even if you don't understand their language, so that in the end you know exactly which ones are most relevant to you and worth translating into a language that you do understand, so that you can read only those relevant texts closely. Right now on your screen, you are viewing the GitHub repo of MLNA. Here you have an extensive README. Please make sure to read the README text after watching this tutorial in order to be able to use MLNA most effectively. There are two video tutorials. This is the link to the one that you are watching right now. If you do not know how to write Python code and you're still interested in using MLNA, there is also an app with an interface that uses MLNA in the background, and if you watch this video tutorial, it will show you how you can use the app. If you wish to follow along, I have prepared a dataset and a Jupyter notebook for you in this folder, Material for Tutorial. So you can pause the video here, go ahead and download the folder Iran Telegraph Data and also the Jupyter notebook, and then you can continue with this tutorial. So I have gone to the GitHub repo of MLNA and downloaded the content of the folder Material for Tutorial. Here you can see a folder containing the dataset and also the Jupyter notebook. In this folder, there is a collection of texts written in 3 different languages: Farsi, English, and French. Now let's imagine that we do not understand Farsi. The only thing that we know about all of the texts that we have gathered is that the topic of all of them is the development of telegraph lines in Iran in the 19th century. To start applying MLNA to the selected texts, you first have to arrange them in a table. I have decided to put them in an Excel table. As you can see in this Excel table, there are the columns text ID and full text. The text ID column contains the IDs that I have given to the texts manually, and the full text contains the content of each one of the TXT files that I just showed you in the dataset folder. All other columns contain metadata about the text. For example, the file name, the title, the source of the text, and the year in which the text was written. But remember, the columns full text and text ID are mandatory. If you do not have these columns in your table, MLNA will return an error and it will not function. Now that you know what your dataset looks like, please go ahead and open this Jupyter notebook called MLNA_playground. If you have not installed the package on your computer already, you can uncomment this cell and run it. You can also alternatively install MLNA via your terminal. In the next step, I'm going to run this cell. Here I'm importing pandas, pickle, and from MLNA, I'm importing 2 modules, network and user input. Then I'm going to read the data set that I have prepared in an Excel table and save it in a data frame. MLNA helps you get an overview of the content of your multilingual text collection by visualizing network graphs between entities from these texts. By running the getEntities function from the user input module, you can define a list of entities that you want to be detected in your text collection. And you can store these entities in a variable called entity tags. Let's run this cell. Here we can see a list of all possible entities that can be detected. I'm interested in people and places in the text, so I'm going to type in person and GPE, and that's it. I enter done, and you can see a list of these entities has been stored in the entity tags variable. In our scenario, I assume that you are researching the development of telegraph in Iran. So you know that the word telegraph should be dominant in your text collection. But this word doesn't fit under the entity tags that you have been presented with here. You can create another list manually and put all words that you want to be treated as named entities and appear as network nodes in your graph in that list. I am naming this list user ents, and I'm putting only the word telegraph in the list. For now, I'm going to jump over this cell and go straight to the next one. Here, I'm calling the visualize network function from the network module of MLNA. This function takes two arguments, textdf, this is your text data frame, and the entity tags. The keyword arguments are the user entities that you have defined, and for now we are not going to use the rest of the keyword arguments. You should give the graph that gets visualized by this function a name. You can also define the size of the graph and also the color of its background and its fonts. I'm going to run this cell now. It takes some time to create the network graph. I will put the video on fast forward, but don't wonder if on your computer it takes more time to create the network graph. The cell has run successfully. Here you can see the message, the network graph was successfully saved to the current file's location as networkvisualization1.html. I'm going to open the folder where I have my Jupyter notebook and double click on the HTML file. Again, it takes some time to open the HTML file. I'm going to put the video on fast forward. There we go. Here's the visualized network graph. Let's zoom in and study the graph more closely. I know there are some flaws in this graph. I'm going to look for them and show you what I mean by them. Here is one of the flaws. The word Nasser-ad-Din and Nasser-ad-Din Shah, these two names actually refer to the same person, to the same king, but they have been recognized as two different entities because they have different spellings, or sometimes when you're working with multilingual texts, they have different transliterations. Also, the word India with capital I and here India with lowercase I, they have been recognized as two different entities. If you study the graph closely, you will realize there are many such doubles. Another one of them is, for example, here, UK and the United Kingdom. They have been recognized as two different entities. In the next step, we want to unify all of these entities that actually refer to the same person or the same place so that you can have a more precise graph. To achieve this precision, let's go back to the Jupyter notebook, to the cell that we jumped over in the previous step, and uncomment the first couple of lines. Here I am calling the make user dict function from the user input module of MLNA. This function creates a Python dictionary in which you can unify different spellings of the same entity so that your network graph becomes more precise. The arguments are textdf and the entity tags. You can also enter the user ents as a keyword argument. For now, you don't need to enter a dictionary path because you do not have a dictionary yet. And here, threshold is the threshold that I'm using for fuzzy matching in case I want to use fuzzy matching. Let's run this cell and see what happens. Here, the function is asking you whether or not you want to see all similar entities and define a constant spelling for them. In other words, whether or not you want to use fuzzy matching. I'm going to say yes. So the function is asking me whether these two names refer to the same entity, Mirza Gafar Khan and Mirza Jafar Khan. I assume that this is correct, so I'm going to enter a unified spelling for both of the names. They should appear like this in my network graph. I press enter, and then the function shows me the second couple of words that maybe should be unified, Peterburg and St. Petersburg. I want to see both of them written as this, St. Petersburg. The next names, Morsi and Morse, I'm not sure whether they refer to a person or a company. It doesn't really matter. So I'm going to just skip over this couple of words by entering S. Here we have different spellings of the word telegraph. I want to choose the first one as a unified spelling for all of them. And also Ali Gholi Khan. This is the name of a person, and I think it should appear like this as the first option. The word Tehran, I want it to appear like this. This can go on for some time, but for now I'm happy with the dictionary that I have created. So I'm going to enter done, and I can see the dictionary that I have created. This dictionary has been saved under the variable userdict and also to my working directory. So I open the folder where my Jupyter notebook is and refresh the folder. Here I can see the user dictionary saved as a pickled file. Using fuzzy matching with different thresholds can save you a lot of time while creating the dictionary. However, there are certain words that refer to the same entity, but they cannot be unified using fuzzy matching because their spellings are very different. For example, having studied the network graph closely, I have realized that the country that we know as Iran nowadays has been referred to as Persia in some of the texts. Or I have different words for the UK, for example, England, the United Kingdom, and I want all of them to appear as UK in my network graph. To unify these spellings, I'm going to go back to Jupyter Notebook and expand the dictionary that I have just created, but this time without fuzzy matching. So let's go back to the cell we were working at, comment out the first two lines, and uncomment the second block of code. Here, I'm going to pass a dictionary path to the makeUserDict function. And the dictionary path is the path to the pickled dictionary that I have just created. So I am using the dictionary that I created before and I'm expanding it, but this time with a different method. I run the function now, and when I'm prompted to enter whether or not I want to use fuzzy matching, I'm going to say no. So now I am allowed to enter the standard spelling of an entity. I want the standard spelling of Persia to be Iran. So I enter Iran here. And what are the variations of Iran that appear in the network graph? There is only one variation, Persia. So I'm going to go to the next key value pairs. Now, the next standard spelling is UK. And the different variations of UK are England, the United Kingdom, and also United Kingdom. So that's it. I enter done. And I can see the dictionary that I created before and the new key value pairs that I have just defined have been added to it. Also, the pickle dictionary that I had in my working directory has been replaced by the expanded dictionary. Creating and applying a user dictionary can do some text cleaning for you and results in a more precise network graph. Among the data that you have downloaded from GitHub, there is also a more extensive user dictionary that I have prepared for you. You can find it here in Iran Telegraph Data folder, App Data, and Telegraph userdict.pickle. Let's load the extensive user dictionary into our code, pass it to the visualize network function, and visualize the network graph again. To do so, I'm commenting out the second block of code here in this cell, and I uncomment the third block and run it. You can see the user dictionary that I have prepared for you. I'm going to run the visualize network function again, but this time I'm also passing a user dictionary, and I'm also changing the name of the visualized graph so that the previous graph is not overwritten. Let's go ahead and run this cell. The cell has finished running. Now I have to go back to the path where my Jupyter notebook was. Here is network visualization _2. And now we have a more precise network graph. I can zoom in and study the graph closely to figure out which entities and relations between them exist in my collection of texts. Each edge in the graph represents the co-occurrence of its nodes in the same sentence. The multitude of nodes in this graph make it hard to read. MLNA offers methods for making the graph more comprehensible. One of these methods is to visualize only the core of the graph. To do so, let's go back to the Jupyter notebook, to the cell we were working in, and set core equal to true. And I'm also going to change the title of the graph to network visualization core and run the cell again. Okay, the core has been visualized. Let's go back to the working directory, refresh, and look at the visualized core. You can see that the core is already telling us a narrative about the development of telegraph in Iran. So Iran and Tehran are two big nodes, and also telegraph. You can see the names of a lot of British cities like London here and Lowestoft. You can see Britain and the Indo-European Telegraph Company. So you can already tell that the British developed the telegraph lines in India and Iran through the Indo-European Telegraph Company, maybe as a unified project. And interestingly enough, you can also see the name of Russia. So apparently the Russian also played a role in developing telegraph in Iran. There are also other ways of making the graph more minimal and more readable. I'm going to go back to my Jupyter notebook, set the core back to false, and this time I'm going to pass the select nodes keyword argument to the visualize network function. To do so, I'm going to uncomment this line. The select nodes function from the user input module of MLNA can help me create a list of nodes that I want to see visualized in the graph. The reason why I'm using this function instead of passing the list manually to the select nodes keyword argument is that I want to make sure that I don't have any typos in the node names that I'm typing, and I want to make sure that every node name that I pass to this function actually exists in the network data and gets visualized. The function is now prompting me to enter the names of the nodes that I want to see in the visualized network. I'm going to add Tehran, but I'm going to add a typo on purpose, and you can see the function returns an error message the name Tehrani is not valid, but it accepts Tehran from me. I also want to see the king Nasser ad-Din Shah in my network graph, Britain, and maybe the Indo-European Telegraph Company. Done. So this list has been stored in the select nodes variable. So I'm going to go back to the visualize network function and set select nodes equal to select nodes, and also rename the graph again and visualize it. Now let's go back to our working directory, refresh, and look at the visualized graph. As you can see, this is a more readable graph. You can go ahead and look at the relationships between these nodes that you have selected. Here is Britain, Tehran, Nasser ad-Din Shah, and the Indo-European Telegraph Company. Another way of creating minimalist graphs is to visualize network relations between entities from a selected number of texts. To do so, in your code, you can set select nodes back to none and go ahead and run this cell. I'm going to uncomment it and pass the sources to the visualize network function. Here, the sources is a list of text IDs. I have selected the texts here that stem from the British Library's archive. So I run this cell, go back to the visualize network function, set sources equal to sources, and rename the network graph and run. Okay, so let's go back to the working directory, refresh, and here are the network relations that exists between the entities detected in the texts coming from the archive of the British Library. Last but not least, to get a better overview of the network relations existing in your collection of texts, you can visualize a community network. To do so, you should go back to the Jupyter Notebook and run the detect community function from the network module. Here you have all of the arguments and keyword arguments, and your graph is going to be named community detection. Let's run it. And let's do the drill again. Go back to the working directory, refresh, and open. And you can now take a closer look at the visualized communities and gain a better understanding of the relationships between humans and places that were mentioned in your text collection. Using MLNA, you have been able to understand which persons, places, and relations between them and telegraph exist in your text collection. Now you can filter out those texts from your collection that you think contain useful information for your research and translate them, if you don't understand the language, to perform close reading on them. Here I'm going to show you 3 different scenarios. Let's go back to the Jupyter Notebook. Here in this cell, in the first scenario, you are interested only in texts that contain the name of the Qajar king, Nasser ad-Din Shah. In the second scenario, you want to find texts that include the relationship or the edge between India and Iran. And in the third scenario, you are looking for texts that do not contain the names of British personalities and companies, but rather those of non-British people and companies. For example, Georg Siemens was a German guy from Germany, and Morse, he was an American person. So you only want to see the texts that contain information about these 3 nodes. Let's look at the first scenario. I'm going to run the filter network data function from the network module, and I'm going to pass one node, the list containing only Nasser ad-Din Shah, to the select nodes argument. And I'm also going to set the operator equal to or because I'm only interested in texts containing nodes, not edges. Let's run the cell. The function returns a data frame which is very similar to my original data frame. The only difference is that it contains 3 new columns. They are source, target, and weight. These are actually columns from the network data frame added to the original one. And here you can see all of the text IDs that contain Nasreddin Shah. So if you're interested in texts that contain this name, you should go ahead and read the texts with these IDs. Now let's look at the second scenario. If you are interested in the edge between certain nodes, you should run the filter network data function again, but this time you're passing a list of 2 nodes to the select nodes and you're setting the operator equal to and. Let's run. You can see that the resulting data frame this time has only 4 rows, and these rows are actually referring to 2 different texts. There are only 2 unique text IDs, and both of these texts have been written in Farsi. In the third scenario, I'm going to look at the texts that contain one of these 3 nodes. So I'm going to set the operator back to or again, and again run the cell. And in the third scenario, the function is returning a data frame containing all of the text that include the names Georg Siemens, Germany, or Morse. MLNA has enabled you to find those texts from among your collection that are relevant to your research, although you may not understand their language. Now you can save the data frame containing the filtered network data to an Excel file that you can use later. To do so, I'm going to run the final cell and go to my working directory, to the folder Iran Telegraph Data, App Data, and here is the filtered text Excel file. If you have any questions about using MLNA in your code, or if you face error messages while using MLNA and you don't know how to resolve them, you can always go to the GitHub repo of MLNA, github.com/goli-sf/MLNA, and you can go to issues and click on create an issue and tell me about your problem or the error message that you're facing, and I will try to help you. Thank you so much for following along. Have fun using MLNA and let me know if it works for you in your research. I would be happy to receive feedback from you. Goodbye.